Second white coat. Subscribe and like. Let's learn medicine together.
All right, let's dive right in. Today we're tackling a massive paradox, one that affects millions of people. How can a medicine that's designed to save your life also make you feel so profoundly, horribly sick? It's a huge question, so let's break it down.
You've probably wondered about this, right? If you've ever known someone who's gone through chemotherapy, you've seen it. And you know, this isn't just some minor side effect. It's a powerful, almost violent biological reaction. So what is actually happening inside our bodies, and more specifically, inside our brains, that causes this kind of response?
So to figure this out, let's start with a case file. We've got a 33-year-old man. He's starting life-saving chemo, and almost immediately, boom, he's hit with this intense, nonstop vomiting. Now the key clue here, the real giveaway, is the timing. It happens right after the drugs get into his blood. That tells us whatever's happening is happening fast. That kind of immediate reaction means the drugs are hitting a central control button somewhere, a chemoreceptor trigger zone, deep in the brain. So, our mission, should we choose to accept it, is to find that trigger. We're basically going on a manhunt, but for a tiny little clump of neurons.
Okay, time to put on our detective hats. To find our culprit, we've got to do this systematically. We're going to line up the usual suspects, the major areas of the brain, and see which one fits the profile of a poison detector.
All right, first up in the interrogation room, suspect number 1, the thalamus. This guy is located deep in the center of the brain, a real hub of activity. So it's a pretty logical place to start our search.
So to see if it's our guy, we need to know its day job. What does the thalamus actually do? Well, you can think of it like the brain's grand central station. It takes in all the sensory info from your body, sight, sound, touch, and routes it to the right place. It also helps manage when you're awake and when you're asleep. It's a busy, super important piece of brain real estate.
But does it fit the profile of our poison detector? Verdict? Nope, not the culprit. See, it's a master of information, but it's not a security guard. It's not designed to taste the blood for chemical threats. So we're crossing the thalamus off our list.
Okay, on to the next one. Suspect number 2, the colliculi. These are a pair of little structures, the superior and inferior colliculi, tucked away in the midbrain.
Now, these two have really specific jobs. You know when you catch something out of the corner of your eye and your head just snaps to look at it? That's the superior colliculus. And when you hear a sudden noise and turn towards it, that's the inferior. They're all about those super fast automatic reflexes to stuff happening around you.
And right there, that's the tell. Their whole job is to react to the outside world, sights and sounds. They're not paying any attention to the chemical conversation happening inside the body. So they don't have the right tools for this job. Verdict? Not guilty. The investigation continues. All right, let's bring in the big guy. Suspect number 3, the cerebellum. This is that large, dense structure at the very back of the brain. You can't miss it, and it is an absolute powerhouse.
The cerebellum is the maestro of movement. It's what lets you walk without falling over, catch a ball, or type on a keyboard. It fine-tunes everything, making sure your movements are smooth, coordinated, and precise. It's a master of its craft.
So could this be our trigger zone? Well, again, the evidence just doesn't line up. We know that when the cerebellum is damaged, people get clumsy, they have tremors, they lose their balance. It has absolutely nothing to do with detecting chemicals and triggering vomiting. So, another dead end.
So we've ruled out all the major players. Where could this trigger possibly be hiding? Well, here's the twist in our story. It turns out our culprit isn't a big, famous part of the brain at all. It's a tiny, specialized area with one very unique and very important feature.
And here it is. Say hello to the Area Postrema. It's tucked away at the base of the brainstem. It's small, it's obscure, and it's absolutely our culprit. And the reason why all comes down to a critical defense system that the brain has.
Okay, think of your brain as the most exclusive VIP club in the world. The blood-brain barrier? Well, that's the team of elite bouncers at the door. It's this super tight layer of cells that stops pretty much everything from getting in from the bloodstream. Bacteria, viruses, most chemicals. It's an incredible security system.
But, and this is the absolute key to the entire mystery, the area postrema is one of the very, very few places in the brain that is outside this fortress. It's like a little security kiosk built on the sidewalk just outside the club's front door. It has no blood-brain barrier, and that right there is the smoking gun.
Because it doesn't have that protective barrier, the area postrema can do something the rest of the brain can't. It can literally reach out and sample what's flowing through your blood. It's the brain's official poison taster, on duty 24/7, constantly on the lookout for anything dangerous.
Okay, so case closed. We've found our culprit, and we know it's secret. So the next big question is, how exactly does it work? And, more importantly, how can we stop it?
The pathway is actually incredibly direct. It's a simple chain reaction. First, the chemo drugs start circulating in your blood. Second, our little unguarded area postrema tastes them and goes, "Whoa, this is bad stuff, this is poison." Third, it slams the big red alarm button, sending a powerful signal straight to the part of the brain that controls vomiting. And fourth, that center does its job, which is to get the poison out immediately. And knowing that pathway is exactly how we figured out how to fight back. See, the area postrema doesn't just scream for help. It sends a very specific chemical message, using messengers like serotonin and dopamine. And that's its weakness. Modern anti-nausea drugs are designed to be antagonists. They literally get in the way and block the signal. It's just like cutting the wire to the alarm bell. The poison is still there, but the warning signal never gets through.
So, after our deep dive into the brain's security system and a full-blown criminal investigation, let's pull all these threads together and sum up what we've learned.
So here's the bottom line. That intense sickness from chemotherapy isn't a flaw in the medicine. It's our brain's ancient, hardwired poison detection system doing its job perfectly. The area postrema, that tiny spot in the medulla, acts like a sentinel because it's outside the blood-brain barrier. It detects the chemo drugs as a threat, and it sounds the alarm. And the only reason we can design drugs to make that treatment tolerable is because we understand that exact mechanism.
And that leaves us with a pretty fascinating final thought to chew on. This remarkable little sensor is on duty, 24/7, always monitoring our internal world. It evolved to protect us from things like spoiled food or natural poisons. But in our modern world, what else might it be picking up on? From all the different substances in our diets to pollutants in the environment, our brain has a direct window into our bloodstream. Kind of makes you wonder, what other signals might it be sending it we don't even notice?